So welcome to Electronics Excellence, and you are watching Signal Systems lecture series. And today the topic of discussion is we'll see what is the relationship between continuous and discrete time standard signals. Okay, so we'll see what is the relationship between the unit step and unit impulse, then unit parabolic, and also unit ramp functions. Okay, so let us begin our discussion. So let us compare between the discrete impulse, that is del of n, and the continuous impulse del of t. Okay. So first one is your, that is the, in case of definition, so del of n equal to 1 for n equal to 0, that is the n 0 otherwise, and del of t equal to 0 for t is not equal to 0. Okay. So this is the definition of discrete time and continuous time delta function. Okay. So the area is, we have mentioned the summation, that is the, it will be equal to 1. Similarly, integration, that will be del of t dt, that will be equal to 1. Okay. So next one is your time shifting property. So it is del of n minus n0, which is equal, of course, actually at n equal to n0. So if n equal to n0, so what will happen is that if n equal to n0, so it will be del of 0. Okay, that will be 1. Okay. Similarly, here also, if t equal to t0, that will be del of 0, that will be equal to 1. So this is property is the time shifting property. Okay. Similarly, is the shifting property. This is the called the summation shifting property, and this is the integral shifting property. Okay. So integration of x of t, if you take a function x of t, del of t minus t0, it will be x of t0. Similarly, this is the summation shifting property. Okay. So even property, actually del of n is a even signal. So del of minus n equal to del of n. In case of continuous time, it is del of minus t equal to del of t. Okay. Next one is your relationship with steps. The relationship with the step function. So del of n equal to, in terms of discrete time, it is u of n minus of u of n minus 1. Okay, this is a very important relationship between the del of n and u of n. Okay. So del of n equal to u of n minus of u of n minus 1. Okay. Similarly, del of t, which is the derivative of u of t. So u of t is a step function. Okay. So this is the relationship between the discrete time del of n and the discrete time u of n. This is the relationship between the continuous time del of t with continuous time u of t. Okay. So again, so scaling, so del of an equal to del of n, whereas in case of continuous time, it is del of t equal to 1 upon a, it is del of t. Okay. Next one is your convolution. So convolution is your in case of this is the convolution integral. So x of n convolve with del of n equal to x of n, whereas x of n, x of t, that is the convolve with del of t equal to x of t. So we will see this property once again. So in the coming videos. Okay. So this is the called the convolution integral. Star is the convolution integral. Okay. So in terms of energy, the energy equal to 1, both cases, in case of continuous time and in case of the discrete time. Power is 0, and this is the power equal to 0. Okay. So there is energy finite and power equal to 0, means it is an energy signal. Okay. So next is your discrete step versus continuous step. So let us see, by definition we can see, so u of n equal to 1 for n is greater than equal to 0, and 0 for n is less than 0. Similarly, u of t, which is equal to 1 for t is greater than equal to 0, and 0 for t is equal to less than 0. Okay. That we have seen in the previous lectures. So this is your u of n, and discrete time is denoted as u of n, and continuous time is u of t. Okay. The discrete step, u of n is the discrete step, and u of t is the continuous time step. Okay. So value is origin, the value is at origin it is 1. In both cases that equal to 1. Okay. Similarly, this is a time shifting property. So it shifts by n0 samples. Here is this is a t. Okay. So this is the t0 samples. Okay. Similar relationship with the step. Okay. We have u del of n equal to u of n minus of u of n minus 1. And in case of continuous time, it is del of t equal to d by dt of u of t. Okay. then integration and summation. So u of n equal to the summation del of k. Okay, similarly in case of continuous time, it is the integral of del of tau d tau. Okay. Then energy equal to infinite in case of discrete time. Also in case of continuous time, it is energy infinity. Similarly, power is half in case of discrete time as well as the continuous time step signal. Okay, so the energy signal type is it is a power signal. Okay, so next one is your discrete RAM and continuous RAM. So this is the definition of discrete time ramp signal. So R of n equal to 0 for n is less than 0 and equal to n for n is greater than equal to 0. Similarly, this is the n is replaced by t only. Okay, so for negative it is 0, for positive it is t. Okay, greater than equal to 0, the value is t. So this is a time shifting property. It is shift by n0 sample. In this case, it is shift by t0 units of time. Okay, so this is the relationship between the step function. So U of n is a step signal, R of n is a this is the ramp signal. Okay. Similarly, in terms of continuous time, this R of t equal to t into U of t. So this is the summation formula, and for finding out unit step, sorry, unit ramp signal, this is the means continuous time. Okay. So energy equal to infinity, power also it is infinity. So it is neither energy nor power signal. Okay. So let us see the relationship between the continuous time signal. So you can see the integration of del of t. What is del of t? Del of t is a unit impulse signal. Okay. So it will integrate this, it will be a unit step signal. Okay. Similarly, integration of this unit step signal, it will be unit ramp signal. Okay. So integration of unit ramp signal, it will be parabolic signal. Okay. So you can check this out. Okay. Parabolic signal equal to, what is the parabolic signal? Parabolic signal equal to t square by 2. Okay. T square by 2. Similarly, what is the ramp signal? It is t. Okay. So if we integrate this, it will get t square by 2. Okay. So this p of t is a unit parabolic signal. Okay. Similarly, it is the uh, derivative. In terms of derivative, it will means differentiate p of t with, of course, with respect to the time. It will be a unit ramp signal. Okay. Similarly, differentiation of unit ramp signal, it will be a unit step. Okay. And last one is your, if we differentiate with respect to time, the unit step signal, it will be a unit impulse signal. Okay. So these are the relationship between the various continuous time signals. Okay. So in this video, we have seen that means uh, differentiate between the continuous time and discrete time, ramp signal, unit step signal, and impulse signal also. Okay. Then this is the relationship between the continuous time, all the continuous times, elementary continuous time signals. Okay. So thank you all. So thank you for watching this video. So if you have any doubt, you can free to ask me in the comment section. Thank you all. Okay.